Hello everyone, my name is Dayan, and in this video we will compare the hand calculations obtained from the shear capacity of a concrete beam to the output given by Altair's S concrete. So we begin by taking a look at our section's given properties. We have the width, which is 250 millimeters, with a height of 500 millimeters. The clear cover of the concrete will be 35 millimeters and a concrete strength of 25 megapascals. Additionally, the steel strength for the river is of 500 MPa, which is divided by the material safety factor to obtain a value of 434.78 MPas. All of these can be directly inputted into S-concrete section dialog as we can see here. Additionally, if we go back to our slides, we can see that with the river disposition as seen here, the steel area can be manually calculated as 603.2 square millimeters, and so is the stirrup area and spacing, with values of 100.53 square millimeters and 150 millimeters respectively. We can verify this by looking at the miscellaneous window in the S-Concrete Visual Editor, as seen here with the same value. Now that we've gone through that, we can focus on the following calculated parameters. The effective depth is of 366.3 millimeters, while the value of C for use in a country might be found in its national annex. The case for this one is for the United Kingdom annex, so the recommended value is of 0.18 in this case. And the concrete partial material safety factor, Y Z, is of 1.5. So with this, we get a value of 0.12. As for the coefficient factor, we have the following formula where we can substitute the values and choose the minimum between 1.7 and 2.0. So we go with 1.7. The width of the beam's web is the same as 250 millimeters, while the reinforcement ratio for shear is calculated through the formula seen here. Substituting value, we get to choose the smaller of the one between 0.02 and the one that is obtained out of the formula. So for this case, we will go with the obtained value of 5.93 times 10 minus third. With that done, we can now manually calculate the expected shear resistance of this section. By simply substituting all the previous calculated values as seen here, we obtain a shear resistance on the z-axis of 51 kilonewtons. We also have an expected shear capacity of 106.74 kilonewtons and a maximum shear resistance of 412.17 kilonewtons. With that clarified, I'm just going to go through S-Concrete's interface and add a bit of representative loads right here in the loads dialog and add shear on the z direction of 30 kilonewtons and moment on the y direction of 45 kilonewtons. I'm going to click OK, and now I am going to let the program to calculate the shear uh, requirements for this one. Once we've done that and that we know our requirements calculated, we can go here to results, report, and we will get the enhanced report. And I'm just going to click here on shear and torsion and take a look at the shear of the z direction um, calculated values. So I can see that these are the values that we have previously calculated, and now we can compare them right next to the ones that we got. So we can put them together in the same slide, and we can see that the calculated shear resistance is of 106.75 kilonewtons, and S-Concrete calculates it at 106.9 kilonewtons. The maximum shear resistance for this section is of 412.17 kilonewtons, and S concrete calculates this as 412.6 kilonewtons. So these results are very similar, and with this we can validate the results that S concrete is having with our own results. That is all for this video. Thank you very much, and see you in the next one.